Let's try to find the radius of convergence of this power series. Now with this format you can see that it is a power series, and from the theorem that we discussed before we know that this power series should also fall under one out of these three categories, right? So now to find the radius of convergence, actually we have to just use the theory of the ratio test, and let's see what category that this series will fall under, right? And to do the ratio test we need an and an+1, so an will be this whole thing, and accordingly we can get the an+1th term, and then when you get the ratio you will have this one. So once you get the limit of this ratio you will have 3 times the modulus of x. And the theory of the ratio test will say that when this limit is less than 1, then the series will converge. That means for such x values, that is when the modulus of x is less than 1/3. In other words, when the modulus of x minus 0 is less than 1/3, then the series will converge. And also the ratio test once again will say that if the limit is greater than 1, then it diverge. That means when the limit of x minus 0, not the limit, when the modulus of x minus 0 is greater than 1/3, the series will diverge. So let's see what are the suitable x values that this equation so that this inequality is satisfied. Well, this is actually, once again you can consider the x values as a distance from 0, right? So in this case the distance from 0 should be within a radius of 1/3. So here we will have negative 1/3, and here you will get positive 1/3. And from this statement it says that the x values which has a distance from 0, and that distance should be less than 1/3. So still we don't know what will happen in the end points, right? We know, but anyway we know for sure that when the x values are in between these two numbers, now this is the way that we represent an interval, and here you have open brackets, so that means the endpoints are not included, right? So within this interval, for x values within this interval, from this statement you can say that the series will converge. And then from this statement you can say when the distance is greater than 1/3. Now this is 1/3 distance, and greater than 1/3 means in this region as well as in this region, and for those values the series will diverge. Now from this theorem you can see that our specific series will fall under the third category. There is a certain positive number, so that the series will converge for the values less than that number. So here in this case the radius of convergence is 1/3. Okay, but still we are not done yet, because we still don't know the convergence of the series at these two endpoints. Okay, because here it says strictly less than 1/3, that is the values inside the interval, and here it says strictly greater than. That means the values outside the region. So still we don't know what will happen in the endpoints. So for the endpoints, we should do the calculation manually, right? So when x is -1/3, we should substitute -1/3 in here, -1/3 for x, and then see what will happen. So when you substitute -1/3 in the series, then the series will be like this. See, instead of x, I have substituted -1/3. So when you have that one, the series will be like this. Now for the convergence of this one, we can either use the integral test, right? Remember we did something called integral test that associates the convergence of a series along with the integral. But you can even, instead of going for these sort of tests, if you just observe the terms, it will be something like this, right? 1/2, 1/3, likewise, right? So instead of starting it from 0 and writing it as n+1, you can even write the same series as n to the power half starting at 1. So these two are the same thing, right? So at once you can see that from the p series test, here the power is less than 1. Therefore this series will diverge. Okay, so whatever the method you use, we have the divergence of the series at x equals -1/3, right? And how about x equals +1/3? So now in the number line or in the interval, we have computed that at this point the series will diverge, right? And how about this one? Then you can see that the series will be like this when you have x equals 1/3. So from the alternating series test, we can say that the series will converge at this point. So in our interval, at this point, the series converges. So now we have figured out all the x values in the real number set that the series converges, and all the real numbers that the series diverges. So if we are to write the interval of convergence, now the radius of convergence is 1/3, right? So that's the basic number that comes from this theorem also, right? And if we are to find the interval of convergence, that is the whole interval, then if we just write it like this, then it is not correct, because this is an interval notation, but here it says we are excluding the endpoints, but it is not correct in this case, because for the converging point we have to include this point as well, right? So we should exclude the left end point and we should include the right end point. So this will be the actual interval of convergence. So for all the x values inside this interval, so when I say inside this interval, because of this closed bracket notation, it includes the right hand point as well. Okay, so for all the x values inside this interval, that is in this region, now 1/3 is included but not -1/3. For all those x values, when you substitute it in our series, it will converge, right? This series will converge for all the x values within this interval. And we have another data outside this interval. when we substitute, the series will diverge, right? And also you have to observe that now in a previous video session we said all power series will converge at the center point, right? So that now here also it should have the same property, right? So for the center point of this series it should converge. That means the center point should be in the interval of convergence, and we can clearly see that here the center point is 0 and 0 is in the interval of convergence. So definitely the center point should definitely be inside the interval of convergence. And also now you have to remember, now when we say interval of convergence, it says two things, right? One is that for all the x values inside this interval, series will converge, and there is an additional data that for the values outside the interval, it will diverge. Say for example, if we substitute x equals 10 in this series, that is this one, 10 n plus 1. So at once we can say that the series will diverge because x equals 10 lies outside this interval of convergence.